with account linking. So account linking is a process that's initiated from within the Google Home app that enables users to authorize access to those devices. So some of you have probably experienced this before, but just kind of talk through the idea. If a user wants to enable their smart home device through the assistant, they go through the Google Home app, they decide they want to add a new device, and they click that they want to link their existing account from some other vendor, like Nest or whoever, to the Google Assistant. That triggers a sign-in flow through this account linking that enables them to log in as that using the account that they had with that partner device, and then authorize that the Google Assistant can have access to all of the devices that are managed by that particular account. What you're seeing here is just a screenshot of the account linking implementation that we have provided in, again, in that end-to-end example that's on GitHub. So smart home account linking really boils down to three primary elements. Now, for those of you who are familiar with OAuth 2.0, this is going to look very familiar because basically what we require of your service is to be able to expose to us an OAuth 2.0 compatible endpoint so that we can do an authorization code flow with your cloud service. Okay? So that basically means we need to be able to handle the authorization step, which is the user signing in and granting access. And then later on in the process, providing access credentials and refresh credentials, which again is a typical OAuth flow for those things. All right, let's move a little bit now to intent fulfillment. So smart home intents enable users to access and control the devices that they've linked through voice interaction, as well as through the Google Home UI. Remember, I kind of showed you both of those as we were going through the demo. Smart home intents, the fulfillment basically requires that you handle three primary intents: a sync intent, a query intent, and an execute intent. So the sync intent is basically provides information to the assistant about what devices does this user control. The query intent allows you to return the current state of a particular device. And the execute intent is what you'll use to modify the state of a particular device. Okay? So let's look at these in a little bit more detail. Maybe. There we go. So the sync intent is sent automatically after account linking is complete. So this is the assistant's attempt to ask your cloud service, what are all the devices that this authenticated user controls, and what can those devices do? Okay? So your job is basically to respond to this intent by providing the metadata about all of the device types and the device traits associated with the devices under that user's account, right? So in this example, the user might, or we might return a response that says this user has 4 light devices in their account. All 4 of them can report the on-off trait, but only 2 of them support brightness, right? Something along those lines. So this is the kind of metadata that you provide in response to a sync. Now, generally speaking, syncs are not performed on a regular basis. By default, a sync is only performed when the account is linked. Okay? And this can be problematic if this is the only thing that your service implements, because it means that if the user adds a new device, they have to actually unlink their account and relink it again to see the new device. Okay? Now, we mitigate this by enabling you to call a method through the Home Graph API called request sync. So if inside of your application users add new devices or remove devices, or maybe just the devices that are there change capabilities in some way, you can use the Home Graph API to tell the assistant to request a new sync. Something has changed, we need you to send a sync again. And when that happens, you'll get the same sync intent so that you can respond with the new set of data, the new set of devices and capabilities associated with that particular user. Okay? So request sync is very important because it enables users to have a seamless experience between the Google Assistant and your application, and not forcing them to manually resync or relink their account or anything like that just because they bought a new device, right? And applied it to an existing account. All right, so the query intent. Query is responsible for reporting the current state of an individual device or a set of devices. In this case, the assistant is asking you for some more specific information about what is this device currently doing? Is the light currently on? Is the thermostat set to 20 degrees or 25 degrees, right? So in this case, your response is going to provide back the actual values for all of the device traits and attributes that you provided that this device was able to report inside of the sync. This includes whether or not the device is online or offline if you're tracking that kind of status. Okay? The query intent is typically triggered when the user navigates to a particular device from the Google Home app, or maybe through voice when they say something like, "What is the temperature in here?" Right? As soon as that request is triggered, then this intent is going to be sent to your cloud service, and you need to send that back with the result. Okay? Now, both the sync intent and the query intent in the end-to-end example that we've been discussing, both of those only have to go so far as Firebase, right? Because in the architecture that we've created, Firestore is the source of truth for all of this data. So I can get all the information I need about what devices a user owns, what they can do, and what the current state of those devices is simply by talking to Firebase. I don't have to actually go all the way and do a round trip to the devices, which is very important because it enables those queries coming back from voice to be instantaneous, right? You're not seeing this long latency while we actually block waiting for something to go all the way down to the device and back, okay? So this enables a much quicker interaction with the Google Assistant. The execute intent enables you to modify the state of your particular devices based on a user command. So this basically comes in and describes a set of traits that should be updated for a given device or a given set of devices. And these can be provided in a group. So you can get an execute intent that says you should modify on, off, and brightness for these 3 lights. Okay? And then you do all of that in a single set. That basically is what allows us to be able to make some of those more complex queries, like turn on the lights upstairs. There could be 6 lights from 3 different vendors in that particular group, and this enables us to make sure that that all happens in a single command. Okay? The response from an execute intent is a little bit different because we're not actually telling the assistant any more information about the devices. We just need to tell the assistant whether that succeeded or not. So you can tell it for any particular one of those devices, did the command succeed? And succeed really means that you know it got down to the device made that change, and reported that it was successful back to you. Okay? So this is a case where you might actually be talking to Cloud IoT Core directly, depending on your application. Okay? In the sample, we don't actually do that. We modify the state of these devices through Firestore. And because of that, the responses back from the device that a change has actually happened is asynchronous. So in our example, we actually return a different state than success, which is pending. Pending tells the assistant that, yes, that command is expected to succeed, but we haven't seen it yet. Okay? You can also tell the assistant if you know for some reason that that command failed because of an error, or maybe because the device isn't reachable because it's not online. Okay? So all that information can be reported back as a result of an execute intent for each individual device. And then, as you might expect, this is the type of intent that your cloud service will see when the user walks up to this device and says something like, set the temperature to 52 degrees. Right? That's going to be packaged up as an execute intent and then sent down to your cloud service. Okay. Now, one additional piece of information here that's relatively important to implement, it's not required per se, but provides a much better experience similar to request sync, is there's another API call through the home graph that we call report state. If the device changes state locally for some reason, maybe it's a light switch and they actually walked over and flipped on the switch. I know it's weird to think of, but it actually does happen. Or maybe they change that state outside of the assistant, right? Maybe in your client application or through the web, they modified the state of that device. This is something where that state change isn't known automatically by the Google Assistant. And by default, this is not a huge problem because whenever the user wants to ask something, you'll generally initiate a query anyway. But queries have latency to them. So what you can do to improve this experience is implementing the report state API, where anytime one of those local state changes happens that you're aware of, you can report that state change to the assistant by providing the exact traits and values that changed for any given device. This can drastically reduce the number of query intents that your service sees, because if there are recent state changes on a device, Google Assistant can actually look those up locally without having to ask you again. Okay? In addition, in cases where, like in our example that I mentioned before, where state changes in response to commands might be asynchronous, so you can't actually tell in response to an execute whether the command succeeded, and so you return pending instead, report state is the way that you can basically tell the assistant, okay, that command has actually changed. Okay? Because it happened in an asynchronous way. You can call this API. This is the new state of the device. Okay? So report state is really helpful for confirming those success of pending commands and reducing the latency between those potential queries by notifying the assistant of those changes as they happen.